So when we talk about measuring temperature, usually we're talking about the various temperature scales that we can use to measure temperature with and how to convert back and forth between them. We're going to talk about four, basically, though we will, of course, focus in particular on two within this class. So we can talk about British unit scales and metric unit scales. And the other distinction we can make is between relative temperature scales and absolute temperature scales. So absolute or thermodynamic scales are scales that are based on absolute zero. Relative temperatures aren't. So the one that we're probably most familiar with is the Fahrenheit scale, which of course is a British unit scale, and it's a relative scale. And so the melting point of water and the boiling point of water in the Fahrenheit scale are at 32 degrees Fahrenheit for the melting point and 212 degrees Fahrenheit for the boiling point. So there's 180 degrees that take you from melting point of water to boiling point of water. The metric unit that we're most familiar with tends to be a relative scale, and that's Celsius. And so the Celsius scale goes from the melting point of water at 0 degrees Celsius to the boiling point of water at 100 degrees Celsius. So the Celsius scale was set up so that the difference between the temperature at which water basically freezes into ice and the temperature at which it boils away to steam is precisely 100 steps. Now, the other metric unit scale that we will use a lot, particularly when we're thinking about entropy within the class, is the Kelvin scale. And so the Kelvin scale is an absolute scale. 0 Kelvin is absolute zero. And so that means that to go from 0 Kelvin all the way up to the melting point of water is actually 273 Kelvin. It's 273.15 if you want to be more precise. 273 Kelvin is probably going to be good enough for any calculations that we're going to do within the course. The boiling point of water, of course, is another 100 degrees above that because the steps within the Kelvin scale are the same as the steps within the Celsius scale. So the boiling point of water is 373 Kelvin. The last scale is that there's also an absolute scale for British units, and that's called the Rankine scale. And so the melting point of water in the Rankine scale is 492 degrees Rankine. The boiling point is 672 degrees Rankine. And again, you can see the same 180 steps between the melting point and the boiling point for water in the Rankine scale. So a couple additional things to point out. One is that you may also have heard of the centigrade scale. And again, that's another name for the Celsius scale. So because there are these 100 steps between the 2 points that the Celsius scale was defined around, it was originally labeled the centigrade scale before it was named in honor of the person who set it up, who was an astronomer named Celsius. The other thing, it's a small detail, but it is worth pointing out. It's degrees Fahrenheit, degrees Celsius, degrees Rankine, Kelvin. So degrees Kelvin is an incorrect term. So just in terms of thinking about how if we want to correctly refer to temperatures, degrees Celsius, but just Kelvin. Now, of course, if we have all these scales, we need to be able to convert back and forth between them. And so the most obvious two that we're going to have to deal with are really back and forth between Fahrenheit and Celsius, simply because we tend to think about temperatures in Fahrenheit. Because Celsius is a metric unit, we might do plenty of our calculations within Celsius. And then the other conversion that we're really going to want to be able to do is between degrees Celsius and Kelvin. And so all of these are equations that you can use to basically say, hey, if you know what the temperature is in degrees Fahrenheit, then you plug that in here, go ahead, crank out this calculation, and it'll tell you what the temperature is in degrees Celsius. Now, of course, if you take this equation and rearrange it, solve it for degrees Fahrenheit, you end up with this equation. So this one says, if you know what the temperature is in degrees Celsius and want to think about it in a scale that maybe makes a little bit more sense to you because of the way that we report, say, temperatures of the weather, then you would plug in your degrees Celsius here, do this calculation, and it's going to tell you what that temperature is in Fahrenheit. So you can take any of these equations and solve them for the other scale. So obviously if we took this bottom one here and solved for Kelvin, well, we would get that Kelvin is going to be what the temperature is in degrees Celsius plus 273. So just sort of rearranging for whatever the one that you want to convert into, sort of solving for that value is the easiest equation to use to convert. And so as an example of just the conversion, let's say I want to think about 7 degrees Fahrenheit, basically that's room temperature. So if I want to convert that into degrees Celsius, well, I'm going to start by using this equation here, which tells me that the degrees Celsius is equal to the degrees Fahrenheit minus 32 times 5 divided by 9. That's the equation I'm going to start with, and now I just need to plug in my temperature in degrees Fahrenheit. So the 70 goes in there, I get 70 minus 32, that's 48, multiply that by 5/9, and it's something just over 21. So this tells me that 70 degrees Fahrenheit is equivalent to 21 degrees Celsius.